What's up everybody? Chris here from Project Option, and in this video we're going to talk about an options gamma. So an options gamma is the option Greek that represents how the options delta is expected to change when the stock price changes. So let's dive right into it. So what is gamma? Gamma is the option Greek that represents the expected change of an options delta relative to $1 movements in the underlying stock price. So if you're familiar with delta, you may know that delta is actually not static. An options delta will change as the stock price changes. Now, that change in the options delta can be predicted by gamma. So gamma represents an option's changing delta or directional risk. Now let's go through some basic examples to show you how gamma is applied to various options. So to estimate an option's new delta after a $1 change in the underlying, you can add the option's gamma to its delta for a $1 share increase, or subtract the option's gamma from its initial delta for a $1 share decrease. So for example, if we have a call option with a delta of 0.50 and the gamma of that option is 0.05, the expected delta after a $1 share increase is 0.5 plus 0.05 or 0.55. Now, if the stock price falls by $1, that call option's delta is expected to decrease by 0.05 to 0.45. Now let's go ahead and look at the put options. So put options have negative deltas. So adding gamma to a negative delta will bring that delta closer to 0. On the other hand, subtracting that gamma from a negative delta will bring the delta closer to -1. So for example, if we have a put option with a delta of -0.35 and a gamma of 0.03, if the stock price increases by $1, the put's new delta is expected to be -0.35 plus 0.03, which gives us -0.32. Now if the stock price falls by $1, the -0.35 delta is expected to decrease by 0.03 to -0.38. So let's go ahead and visualize gamma's impact on call and put options with stock price increases and stock price decreases. So since gamma is added to an option's delta when the stock price increases, call deltas will get closer to +1 and put option deltas will get closer to 0 as the stock price increases. Now that's because adding a positive number to a positive number brings that positive number higher, and adding a positive number to a negative number brings that number closer to 0. Now since put options have negative deltas, adding a positive number to a negative delta will bring that delta closer to 0. Now after stock price decreases, call option deltas will approach 0 and put option deltas will get closer to -1. Now that's because we're subtracting gamma from the option's delta. So since call options have positive deltas between 0 and 1, subtracting gamma will reduce that call's delta and bring it closer to 0. On the other hand, subtracting gamma from the negative put delta will bring that put delta closer to -1. So all you need to know here is that as stock prices increase, call options become more sensitive in terms of direction, and put options become less sensitive. On the other hand, when the stock price decreases, call options become less sensitive and put options become more sensitive. So to back up that last statement, let's go ahead and look at a visual example of call and put deltas as the stock price changes. So as we can see here, we're looking at the Apple stock price in the top half of the chart, and we're looking at the call and put option on the bottom half of the chart. Now we're looking at the call and put option with the same strike price. So initially, this call option had a delta of 0.75, while the put option had an initial delta of -0.25. So, as we can see here, in the shaded region, the stock price rallied from $120 to $132.50. Now, when that stock price increased, that call option's delta increased from 0.5 to around 0.80. On the other hand, the put option's delta moved from -0.50 to -0.1. So as we can see here, when the stock price increased, the call option became more sensitive in terms of directional exposure because its delta was getting closer to 1, but on the other hand, the put option was becoming less sensitive to movements in the stock price because the put option's delta was moving closer to 0. Now in the last half of that shaded region, the stock price crashed from 132.5 down to 115. Now, as we can see, over that period, the call delta fell from over 0.75 down to 0.25, while the put options delta also fell from negative 0.25 to negative 0.75. So when the stock price decreased significantly, the call option became less sensitive to movements in the stock price, and the put option became more sensitive to movements in the stock price. So all we're showing you here is that when the stock price increases, call option deltas increase and put option deltas get closer to zero. And on the other hand, when the stock price falls, call option deltas get closer to zero while put option deltas get more negative. So at this point, I know you've been wondering why an options delta changes when the stock price changes. And I think it's best to approach this from a probabilistic mindset. So to accomplish this, let's look at two options at the same strike price in two different scenarios. So the first scenario is where the stock price is at $100 and the strike price of the call and put we're looking at is also $100. Now, if you don't know this already, delta is actually used as a proxy for the probability of an option expiring in the money. Now, according to random market theory, there's a 50% chance that a stock price increases or decreases from its current level at any point in time. So, since the strike price of these options is equal to the stock price, it makes sense that the call and put delta are both around 0.5. That's because there's a 50% chance that the stock price increases from 100, and there's a 50% chance that the stock price decreases from 100. Now, if the stock price increases from 100, the call will be in the money, and if the stock price decreases from 100, the put will be in the money. So the deltas of 0.5 in both cases are telling us that there's about a 50% chance that either the call or put is in the money at expiration. Now let's say the stock price increases to $105. Now that 100 call has a 65 delta while the put has a negative 35 delta. Now that means that there is a lower probability that the put expires in the money and a higher probability that the call expires in the money. So more specifically, the call's delta of 0.65 means that there's a 65% chance that the call expires in the money. And the negative 0.35 delta of the put means that there's about a 35% chance that the put expires in the money. Now this should make sense because, remember, initially the stock price and the strike price were the same, and we established that there's a 50% chance that the stock price increases and a 50% chance that the stock price decreases. So naturally there's a 50-50 chance that either the call or put will be in the money at expiration. However, with the stock price at 105, there's a much greater probability that the call expires in the money and a much smaller probability that the put expires in the money. Now this is because the call is $5 in the money, so the stock price can fall as much as $4.99 and it will still be in the money. However, for the put to be in the money, the stock price has to fall more than $5 before it expires. So naturally, it makes sense that the call has a delta of 0.65 and the put has a delta of negative 0.35 because the call's delta is telling us that there's a much higher probability of the call expiring in the money than the put expiring in the money. So where I'm going with this is that since an option's delta is a proxy for the option's probability of expiring in the money, and an option's gamma is the expected change of an option's delta as the stock price changes, you can think about gamma as the change in an option's probability of expiring in the money as the stock price changes. So, to get back to what we were talking about before, as the stock price increases, all else being equal, there's a higher probability of call options expiring in the money because that stock is either now closer to the call option strike price or the call option is deeper in the money. Now, at the same time, when the stock price increases, there's a lower probability that puts expire in the money because either those puts are further out of the money now or their strike prices are not as much in the money. Now, if we go to the other side of things, when the stock price decreases, all else being equal, put options have a higher probability of expiring in the money, while call options have a lower probability of expiring in the money. Now that's because as the stock price decreases, the stock price will either be closer to a put option strike price if it's out of the money, or that put option will be deeper in the money if the option strike price is above the stock price. Now as it relates to call options, when the stock price decreases, either the call option's strike price will not be in the money as much, or it will be further out of the money. And in both cases, there will be a lower probability of that option expiring in the money. So now that you know how to conceptualize gamma and you understand how it applies to delta, let's talk about which options have the most exposure to gamma. So the first consideration is the option's strike price. So in this visual, we're just plotting the gamma of call options and put options at every single strike price. Now, as we can see here, the options that are closest to at the money have the highest gamma values, while in the money and out of the money options have lower gamma values. Now, if we get back to the probability discussion, deep in the money or deep out of the money options probably have a similar probability of expiring in the money as the stock price changes up $1 or down $1. However, at the money options have more significant changes in their probabilities with a $1 change in the underlying. So that can help you conceptualize gamma in terms of probabilities and why deep in the money or deep out of the money strike prices have lower gamma values. So another factor that contributes to an option's gamma exposure is the amount of time until that option expires. So in this visual, we're looking at the gamma values for every single option at every strike price, and we're looking at those gamma values in different expiration cycles. So the red line is the 14-day expiration cycle, and the dark line is the 197-day expiration cycle. So as we can see here, the at-the-money options have the highest gamma values over all time frames. However, the nearest term option cycle has the most gamma exposure for the at-the-money options. Now that makes sense if we get back to the probability discussion, because let's say we have a $200 stock and we're looking at $200 options. So options with a strike price of $200. With 14 days to expiration, if the stock price decreases by $1, that's going to have a significant change on the probability of that option expiring in the money or out of the money. However, if we have that same $1 movement, over a 200-day time frame, that $1 movement doesn't really have as much significance as it does over a 14-day time period. So that explains why at-the-money options with near-term expiration cycles have the most exposure to gamma. Now, what about in-the-money or out-of-the-money options? Well, as we can see here, the expiration cycles with more time until expiration actually have higher gamma values for the in-the-money and the out-of-the-money options. So for example, let's look at the 190 strike price, and let's say we're looking at the 190 put. So with 14 days to expiration, the 190 put's gamma is very, very low. Now that's because if the stock price moves from 210 to 209, that option is still significantly out of the money, and there's only 14 days left for the stock price to decrease down to 190 and for that 190 put to be in the money. So to demonstrate the difference between at the money, in the money, and out of the money option gamma, we're going to look at a couple examples of various scenarios going into expiration. So in this first example, we're looking at an option that is at the money as expiration approaches. So we're looking at a put with a strike price of $120. Now as we can see here, the stock price is trading right around $120 going into expiration. Now we can also see that the gamma, which is the bottom chart, we can see that the gamma is increasing significantly in those final days to expiration. Now as we can see, up until that shaded region, the delta of this option wasn't really fluctuating that much on a daily basis. However, in those final days before expiration, the options delta went from -5 to -0.25 and then all the way down to -1. Now those are some pretty massive fluctuations for very small movements in the stock price. And that's, as we talked about, since there's little time until expiration, each movement in the stock price has a significant change on the option's probability of expiring in the money. And that explains why the option's gamma is surging. Now in this example, we're looking at the option gamma of an in-the-money option as expiration approaches. So over this time period, we're looking at a put option with a strike price of $135. Now over this time period, the stock price is below $135 the entire time, which means that put option is in the money. Now, the first thing I want to point out to you is is getting back to the probability discussion. So in the beginning of this period, the stock price is at 110, which is $25 below the put's strike price. And the put's delta is around 0.85, negative 0.85. And that represents an 85% chance that the option expires in the money at expiration. Now, as we can see here, the stock price rallied from $110 to $130. Now, since the stock was getting closer and closer to the put strike price, the probability of that put expiring in the money was falling. And in fact, we can see that the delta rose from, it was initially at negative 0.85, or an 85% probability of expiring in the money. But then it rose to negative 0.6, which only represents a 60% chance of expiring in the money. So as we can see here, this kind of validates that an option's delta represents the probability that that option expires in the money. Now, as we can see here, the stock price did eventually fall from $130 down to $120. Now, as expiration approached, we can see that the delta of that put went from negative 0.65 all the way down to negative 1. And in those final days before expiration, the put's gamma was also decreasing. And that's because with the diminishing time until expiration, there was less time for the stock price to increase, and therefore there was a higher and higher chance that that put was going to expire in the money. So that explains why, one, the options delta was approaching negative 1, and also why the options gamma was decreasing, because those $1 changes in the stock price didn't have any impact on the option's probability of expiring in the money. Now, in this last example, we're going to look at out-of-the-money option gamma. So before, we were looking at the put option with the strike price of 135. Now we're going to look at the call option with the strike price of 135. Now, as we can see here, since the stock price was never above 135, this call option was never in the money. So as we can see here, when the stock price was at 110, the options delta was around 0.1, or a 10% probability of expiring in the money. However, when the stock price rose to 130, the call options delta rose to 0.35, which represents a 35% chance of expiring in the money. However, as we know, the stock price did fall back down and the options delta fell, but also in the final days before expiration, the options gamma was also decreasing. And that's because with less time until expiration, there's less time for the stock price to increase, and therefore less time for that call option to become in the money. So therefore, that explains why the options delta decreased towards 0, and the options gamma also decreased, because with 1 day till expiration, there's no difference between Netflix being at $120 and $121. There's still pretty much a 0% probability of that 135 call expiring in the money. Whew. Well, I know that was a long one, but we finally made it. So let's go ahead and recap all of the things that we've talked about in this video. So first of all, gamma represents the expected change in an options delta as the price of the stock changes. In other words, gamma measures the change in an option's directional risk. And as we've talked about in depth, an alternative way to interpret gamma is the change in an option's probability of expiring in the money. Now that's because delta represents the probability of an option expiring in the money. Now, when the stock price increases, an option's delta is expected to increase by the amount of its gamma. So call deltas will get closer to +1 and put deltas will get closer to 0. Now, when the stock price decreases, an option's delta is expected to decline by the amount of its gamma. So as a result, when the stock price decreases, call deltas get closer to 0 and put deltas get closer to -1. Now lastly, we talked about the options with the most exposure to gamma. So at the money options that are near expiration have the highest exposure to gamma. Now on the other hand, in the money and out of the money options have the lowest exposure to gamma, especially when expiration is near. Thank you so much for watching, everybody. I know gamma can be confusing, but hopefully through this video you've learned how to think about gamma and how to conceptualize it in terms of probabilities. If you enjoyed this video, please go ahead and subscribe to our YouTube channel so that you can receive all of our new videos as they come out.